Hi, I'm Joyce, and I'm going to be taking you through my extensions for the simulation. First, I'm just going to run the basic foundational part of this problem set, which was implementing the infected and the deceased classes here. So that's what I'll do now. And you can see here that in the dark gray is the recovered, the blue is susceptible, red is infected, and then the light gray, which are the small x's here, are the deceased. And there's a lot of oscillation between the susceptible and the infected, but we end with a pretty good portion of recovered. Next, I've added back in one of my extensions, which is this quarantined class here, and I'm just going to run the simulation with this. And the quarantined people are centralized here in this central pink dot, and after a certain number of time steps in quarantine, they go back to their original position. But we can see here that this was very effective, and the disease is eradicated by the end. So we see this example of effective quarantining, and that is because our proportion of infected people who do self-quarantine is at 2% right now. So if we make this really, really small, like a whole order of magnitude smaller, and we rerun our experiment, then we will see that, again, tracking this pink dot here, that by the end the disease is very much not eradicated, as we still see many infected people, but still just a very thin line of people quarantining at the top. Next, say that we add in a hospital, and basically what happens in the hospital is that anybody who is infected that goes in will become recovered. And so we can run the simulation with this hospital that is seen here. It is this big green circle, and so any infecteds that walk in there become recovered. And the impact that we see on our overall chart here is that compared to the baseline simulation that we ran first, there is a lot fewer infected at the end and just throughout than there was before. So now suppose we introduce vaccines. So we have this vaccinated susceptible class and this vaccinated infected class here. And what the vaccinated susceptible class basically takes advantage of is a vaccination period. And during this time, if a person becomes infected, then their infectiousness to other people will be lower. And returning to our vaccinated infected class, this is what they become. They become a separate vaccinated infected person versus the regular infected. And so we see here that the vaccination recovery period, or the recovery period for a vaccinated person is much shorter, as well as the mortality rate is lower. And the quarantine proportion for people who are infected but vaccinated is higher. The infectiousness of a vaccinated person will also be lower than for a non-vaccinated person. And so now we run our simulation, and we can track the vaccinated people, the vaccinated susceptible people in the dark blue, and anybody who is vaccinated and becomes infected will be in the purple. Now recall that the proportion of normal people who quarantine was kept really low for this, so there isn't much change. But now if we go back and we change our proportion of people who quarantine back to 0.02 and run our simulation again, and this time we're going to see that the combination of vaccines and higher level of quarantine is much more effective. Again, tracking the different colors on our chart here, we see that the numbers of infected basically are flattened out near zero. And so numbers of recovered, quarantined, and vaccinated all go down too. The disease is basically eradicated and levels of deceased are really low. So we notice that in comparison to the earlier quarantine case that eradicated the disease, the difference is that the disease got eradicated pretty rapidly in that case, since there was a small spike in infected at the beginning, and then a proportion of these infected went into quarantine, and this was enough to gradually phase out infection. In the case of vaccination and quarantine, we see a similar flattening out to very low levels of infection. The disease doesn't fully disappear, but this is likely due to just the random nature of our simulation. So I hope that you have enjoyed running these experiments with me, and thank you for listening.